basic statistics. So, girls, here's some words. A population is a collection of individuals about which we want to draw conclusions, but it's the whole collection. So if I want to know about adults in Sydney, I actually have to consider every adult in Sydney. Whereas a sample is just a group of that, like a random group of those adults. Census is the collection of information from the whole population. Whereas a survey is a collection of information from just a sample. An outlier are data values that sit away from the rest of the data. Okay, so you know all that. Data. Now, I don't know if this rings a bell. So data information about individuals in a population. The parameter is a numerical quantity measuring some aspect of the population. So it could even be like the height of every person or the weight of every person. It's kind of like a variable, you know, like some aspect that we're measuring or surveying people about. A statistic, a quantity calculated from data gathered from a sample. So a statistic is like the mean or mode or median. Now, the distribution, the pattern or shape of the data. Now, symmetrical, the last one there is really easy. But do you remember these others, negative skew and positive skew? Does anyone know how to tell if it's negative skew or positive skew? Does anyone know? In a number line, if you got 0 there, and you got 1, 2, 3, this is the positive direction, isn't it? And then the other side is the negative. We are actually using that, but here's the weird thing. Here's how we're using it. We actually look at where the tail is pointing. So see this kind of long tail? See how that's pointing in the negative direction? That's how you know if it's negative or positive skew. It's not where the big part of the body is. It's actually where the tail is pointing. And so do you see with the positive skew, the tail's pointing in the positive direction now? Types of data. Data may be categorical or numerical. So categorical is like what type of car you have, whereas numerical is how many cars you have. So if you're answering in a number, even if it's a decimal, that's numerical. If you're answering in a word, that's categorical. Categorical data is when we get, words and names. Now, discrete numerical data are whole numbers, often as a result of counting. So usually it's whole numbers. So for instance, if I ask you how many cars you have, you're going to say 0, 1, 2, 3. Well, that's actually discrete because there's a gap between 1 and 2. You pretty much can't have 1.35 cars. Do you know what I mean? But continuous numerical data can be decimals as a result of measuring. So here you can always have in-between values. So no matter what two values you pick, technically you can always find in between. So for instance, if I ask your height, and you might be thinking, that's just like 163 centimeters. But technically, it's probably not exactly that much. With a really precise measuring device, it might be 163.2. And even with a more precise measuring device, it might be 0.25. And then 4, and then 3, you know what I mean? So when you measure something, technically there's always a bit of an error, or in other words, you can always go actually more accurate and more accurate and more accurate to get really, really precise in between. Does that make some sense? Now, the one that's a bit tricky about this is something like shoe size. What's tricky about shoe size? Shoe size, not shoe length, but shoe size is usually a 5 or a 5.5 or a 6 or a 6.5. I've always thought it was discrete numerical. The reason is because if you think of a shoe size of 6.5 and 7, can you have anything in between that, like 6 3/4? As a shoe size, I'll buy a 6 3/4. No. So it's definitely not continuous, but technically, or are they categories? A year group were asked to run 100 meters, a sample of 20 times in seconds were taken. In other words, 20 running times. Okay, so there's all the seconds. Now, put the data in a class table. Display the data in a frequency histogram. What shape does the data have? And what is the model class? Now, first of all, girls, is this First of all, categorical or numerical data? Numerical. Is it discrete or is it continuous? I agree, because it's measurement. Even though it's time, it's still measured. Now, all of those are to one decimal place, but if they had a better measuring device, they could even go to 2 or 3 or 4 decimal places. Does that make some sense? Okay, cool. So now, put this in a class table. I wonder if you remember. Let's just draw something up. You might use a ruler, but I'm a bit lazy, so I'm just going to do this. Now, so we're going to put class, and then we're going to do a tally. And then we're going to put a frequency. So, girls, the question is, what are these classes? Now, girls, have a look through that data. Can you find maybe the smallest data value?
12.1.
I think I agree. Okay, so, girls, who can find the highest one? I can see 18. Is that the 18? I want my classes to cover values between 12 and 18. You could actually do this way. I might show you. Don't copy this down yet because we haven't decided. You could do 12.0 to 12.9. And then, what would the next class be from? Yes? Yes. Oops. 0.0 to 13.9. So we could do that way because there wouldn't be too many classes. There'd be 12, 13, 14, 15, 16, 17, 18, 7. That's a reasonable amount. You could also even do 12.0 to 13.4 or 5, but you've got to make sure they're all starting around the same, kind of like following a pattern. You can either on the x-axis just plot the class centers, or you can do the endpoints of the class, like 12, 13, 14, 15, and do the columns between there. That's probably the easier way, but can I just show you now what I mean? So either you can go up by mainly let's focus on the IB way from 12, 13, 14, 15. Just watch this. Just watch it for a second. So let's say I go 12, 13, and have it evenly spaced. 18. And then, actually I think I have to go up to 19. I'll talk about that in a second. So then, what's the highest frequency we got? Frequency 5. So I can just go up by 1s to 5. 1, 2, 3, 4, 5, and 0 at the bottom. So now, my class from 12 to 13, the column starts at 12. I think it's going to 5, is that correct? But the column ends at 13. And all your columns should touch. Does that ring a bell?
Yeah.
Okay, cool. Keep going. What's the next few numbers? I forgot. 3? 3. 3. 2. 3, 3. And a 1. 3. Oh, am I not great? 3. 1. Hopefully you have a grid book and it's a bit easier for you. So it should look something like that. What do you think this axis should be called? What letter? F for frequency. Because that's the numbers that are on there, aren't there? Frequency or F. Now, I briefly mentioned before what letter the data should be. X. Just because generally that's what we do. We let the data be X. I just want to show you how you could have also done it. Instead of doing the end points, you could have just done the class center. What was our first class center again? And you put that in the middle. Does that make sense? You could have also done it this way, 13.45, 14.45, and so forth. Oops, 45. Does that make sense? So you either do a frequency thing, either doing the class centers or the end values. I kind of like the end values more though. It says, what shape does the data have? Let's do a rough shape. Watch this. Just roughly. It's definitely not symmetrical, but if you did like a rough sketch, you don't have to, but this is kind of thing you want to visualize. Would you say that's positive skewed or negative skewed? Positive. Just positive, yeah, just mainly because of this guy here. But it is positive skew, I agree with that. Is the last one, what is the model class? Yeah. Does anyone know what I mean by model class? Yep. I cheated, but most common class. Yes, it's like the mode, but for a class. So girls, which class had the highest frequency? 12 to 12.9 or the X between 12 and 13. So it's however you want to write it. So measuring the center of data, you know this. The mode, most common score. Model class, most common class. The mean is just the average. Now, this is some new notation that you may not have seen before. X with a line on top is another way to write mean. So instead of writing the word, you just do X with a line on top. And again, X is generally what's used to represent the data. So it's the data mean. So yeah. Now, it says it represents the mean of a sample. So if I'm like in my context, if I'm considering all women age 18 in Sydney, but I only consider a sample of them, I would write X with a line on top. But if I actually get data from all of them, I would use this thing which is called it's called mu. Not mu, but M with a U, mu. Okay, it's weird. It's a Greek letter. So this one here, it represents the mean of the population. So if you do have all the data, great, use that. Which one do you use and when? Sometimes you just don't know. So I would recommend assuming population if you're not sure. Okay? Not the end of the world if you get the notation wrong. It's not so important. Now, the median equals the middle score or the average of the two middle scores when the scores are in order. Does that ring a bell? So for instance, if I had this data, just some short data, 1, 2, 4, 5, and 8, what's the middle score? The one in the middle. 4, that is the median. But girls, look at this. If I add a 9, now there's not one middle score anymore. There's two middle scores. Does that make sense? There's these two in the middle. So now, to find the median, you would do 4 plus 5 over 2, or in other words, the average of the two middle scores, okay, which is 4.5. So that's from last year. Now, what is all this about? Now, when it's a small list like this and you can see the median, fantastic, it's so easy. But what if there are 100 scores? I don't want to write each of those out. Do you know what I mean? So here's a trick. If there are n data values, the median is the n plus 1 over 2 score. If n was 11, so there are 11 scores, 11 plus 1 over 2 equals 6, so the median is the 6th term. Now imagine that for a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you were to move inwards to find the middle, do you know what I'm doing? You go cross these out, cross them out, cross these out, cross these out. Oops, there. That's the median. See how that's the middle? And I'm just pretending there are numbers there. And notice how it's 1, 2, 3, 4, 5, 6. It is the 6th term. It worked. It's not that the median equals 6. The median is just the 6th term. Does that make sense? Okay. So if n is 12, the median is the 12 plus 1 over 2, which is 6.5 term, which means the median is the average of the 6th and 7th term. Does that make some sense? So here, if there was an extra term, the middle would actually be here, so you'd find the average of the 6th and 7th. The number of students arriving to school late over a 14-day period are as follows. Find the mode, median, and mean. You know what? I'm finding it a bit hard to find the mode and median as it is. What could we do? Put them in order. Let's do it. Someone help me. What's the mode? It is 6 because now I can clearly see there are 4 6s, but there aren't that many of anything else. So the mode is 6. Take a moment. What's the median? It might be, I think it probably will be, but I might even do the cheat way, which is just move in. So cross, 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 cross. Oops. Yeah, actually it ended up being the average of these two, but because it's the average of 6 and 6, that's just 6. Does that make sense? Do you agree?
Yeah.
Okay, let me know if I did it wrong. Okay, finally the mean. What do I do? I can't see this, I have to calculate it. What do I do? Add them all up. Sum of them divided by how many? Exactly. So I'll let you do that. There are 1, 2, 3, 4, 5, 6, 14 scores. So can someone just find the sum for me? I'd like 75, that's the sum. So what is 75 over 14? 5.3, what? 5.3? 5.7. Okay, just as a reminder, that's 5.36 into 3 decimal places, isn't it? Feel free to round to more, but never less. So girls, that kind of makes sense because like our average-ish or mean and mode and whatever, they usually should be around the same, particularly if the data is symmetrical. However, if it's skewed, they can be quite different, so that's okay. If 5 people have a mean height of 164, what's their total height? It's like on average, there are 5 lots of 164, so their total is just 5 times 164. 820? I could be wrong. 820? Okay, good.